Hello and welcome to my presentation on addressing open source model sharing challenges for scikit-learn and how to tackle them. I'm Merve and I work at Hugging Face, and I'm one of the core developers of skops, this library that we are developing. So when it comes to open source ML, there are several challenges to sharing models. One of them is security. As you might know, Pickle is not that secure. It might execute arbitrary code on your local machine. And it's normal, as it's not built for machine learning, but rather for Python in general. And by means of reproducibility, we mean the reproducibility of a model. So assume that you have a model and you want to get the same model. So you actually need to version a model with its own documentation and some code for reproducibility. And you might not see it in the internet, especially some of the papers are lacking too much reproducibility and the checkpoints are not shared online. And it would be nice if models were actually hosted publicly with an interactive playground, so that you could know what a given model does without actually trying to download and using it. And for this, we are currently developing skops or skops. You can call it however you want. We try to address these problems. And firstly, we try to tackle secure serialization with a new serialization format specifically developed for scikit-learn. Secondly, we version models with model cards that you can programmatically fill, and they help us document the models. And third is integration with Hugging Face Hub, where all of these meets and you can try the model without running on your local. And I will go through how you can interact with API later, but I just want to say that this presentation is set according to how a typical workflow with skops works. Firstly, after your training is done, you create a local repository on your machine. And this repository, once initiated, it contains a model config, a model card, and the model that you have saved it in, and I will show you how to create that. But why do we have so many files? So model card is essentially for reproducibility and model documentation. The configuration file contains features, a sample from the data set, library versions used to train the model, and the task that you're trying to solve. And this is used in, firstly, the inference widget that I'm going to show you later on, that you can go to a models repository online and just try the model. And the inference API, which powers this widget, and also you can send a request to this inference API without downloading and using the model, which is just better than downloading it. And then it's really good for anyone who would like to try your model and see what it does before using it for their own use case, if they want to do that. And to get started with the local repository, you can easily save the model. You can save it with Pickle as well, but you can also save with skops format that I will go through later on, and then initialize the repository. You will pass the requirements. Again, the task that you are trying to solve, it can be tabular classification, tabular regression, text classification, it can be anything. To the path to the directory, the repository will be created in your features and the path where the model is saved in, and then it will create this, it will have this repository, it will create this repository, save the model inside, create a configuration file that is a JSON, and that's it. And we are currently working on initializing the model card automatically, because some information in this configuration can be used to also create the model card. And what does this JSON contain? It contains column names, requirements, a piece of your features, like piece of your training data that people can actually see and, see that maybe they can use the model. The name of the model file and the task that you are trying to solve. And this is later on used for the inference API, as I have said. And what is a model card? So model card is essentially a README markdown file, but we have a separate class for it so that you can programmatically create that. And it's a documentation that contains information about your model. It can contain anything, including a description of your model, description of the data set, limitations about the model, metrics, tables, plots, and more. You can add all of these just programmatically. And by default, when you initialize the model card, which I will show you on the next slide for the API, a hyperparameter table is written to this model card. The plot of the model, like an interactive HTML plot of the pipeline or model, if you're saving a model, is saved there. And also a snippet to use the model so that people can actually know how to infer with your model is saved. And as I said, you can programmatically create the model cards and add information, and this card object is later rendered to a markdown file during the save. The sections to be filled are previously defined with a Jinja template. You can just change that. Like, we have a default template that you can see in this tutorial, but you can just define your own template and just use whatever you want. Yeah. And once you create that Jinja template, you can inject any value as like in this code snippet by calling add on the model card. And you can also add tables, plots, metrics, and more. Like, so long as it's an image file, like you can save any plot that you created with matplotlib or graphies or whatever, you can just save them. Metrics are later turned into a markdown table, and the tables are, we use tabulates to create them. And for the API, there are section-specific methods, and we have add plot that you can pass the plot name, the plot path, and add multiple plots at once. And the same goes for adding metrics and tables. And this is one of the sections that is automatically created for you. This is an interactive HTML plot that includes the components of the pipeline and toggles open for various parameters that the component has. And this plot breaks, unfortunately, the readability of the model card if you're opening the raw MD file without seeing it through a markdown reader. So there is an option to actually turn it off as well. And another one is hyperparameter table of the model is automatically generated and written to markdown table, which is cool for versioning your model. And for the serialization, this is an experimental feature, and we welcome the feedbacks. That would be nice if you could try and let us know how it goes. And this model format is essentially a zip file that contains parameters as bytes and model-related attributes as JSON. We don't use reduce that Pickle uses, and we avoid Pickle. And the audit feature as of now is released, and the format supports native scikit-learn, SciPy, math, and NumPy objects to be serialized. And I will explain more about this feature during the while I'm explaining the API, because that makes more sense. So you can simply dump the model by passing the model and the path to dump. And the tricky part is about the loading the model. So the responsibility of loading a model and trusting the components is in users' hands. So you pass the model path and the trusted parameter. And this trusted can be a Boolean, either true or false. And it can be a list of the trusted types, which we can retrieve. You can, as for what is trusted, anything that is by default existing within PyData stack, like SciPy, scikit-learn, math, anything is trusted. You can have custom transformers and function transformers in scikit-learn. And so long as they contain functions from math, SciPy, and more, they will be trusted. However, if you have custom code, it will not be serialized. And in here, I have a pipeline with a divide column custom transformer from scikit-learn, and a pipeline and the decision tree regressor. These currently seem to be untrusted, but we will soon include them in trusted. You cannot load without passing a value to trusted, and this puts responsibility on the user to trust this file or not. So you can either pass true, meaning that you trust this file and what it contains, or you can pass the types that this list of types that this file contains. You cannot also pass something like, let me not get this divide column custom transformer and let me get this rest. You cannot also do that. This will fail. And lastly, for integration with Hugging Face Hub, you might not know about Hugging Face Hub, so I will explain a bit. So Hugging Face Hub contains, you might also know Hugging Face with only transformers, but we host every library. We have model repositories, dataset repositories, and something that we call spaces, which contains applications that are made with Streamlit, Gradio, or JavaScript, whatever you want, we host it. And we have our model repositories are essentially hosted with Hugging Face Hub, and this is done through Hub Utils module. And I wanted to check if there is any problem. Okay, there's not. Once your local repository is pushed and is public, so you can also set this repository on Hugging Face Hub to be private as well. Anyone can try your model in a widget or through sending a request without downloading the model, but we also wrap this in a function, and I will show that. And the markdown is automatically read on Hub, does make it easier to read, so you can have anything that is marked down and it will be nicely put over there. So while calling push, you could just give repository ID and path to a local repository to push your model to Hugging Face Hub. And this is the hosted inference API that is powered by something we call inference API. It's about sending requests to an API to infer with the model where there is like a data section and like it contains whatever you want to infer from the model. And this is the main reason why we have a lot of content on config. So as you can see here, firstly, the fact that the tabular models do not have universal features like images have pixels or the text have words or like audio has signals. Like it's unfortunately not a it doesn't contain a universal feature. So you actually need to define the columns and the possible things it can contain, the data types of those columns in order to infer with them. So in the config, that's why we have columns, the example data, and the task that you're trying to solve, so that this hosted inference API is actually constructed with a table. For instance, if you have a tabular regression, this will return this will have like a table format you can input your things with, and then it will return a number, which is very cool. And we have wrapped this whole sending a request process with the get model output. So you can infer with the model without downloading it by calling get model output with your model ID and the data you want to infer. And with this, you don't necessarily need to do inference. By downloading the model. And lastly, for Gradio integration. So basically, Gradio is a library that you can use in order to build demos to your machine learning models or data applications. And Gradio recently introduced like the tabular components to have better data science related workflows rather than unstructured machine learning workflows. And we have developed a Gradio integration that is powered by this inference API. So like you have 2 lines of code, and just a second, did I not put that? So sorry, apparently I didn't put it, but basically what you do is you load an interface with only one line of code. I can write this into the chat later on, and it will load this interface. So basically what's happening is that Gradio infers what this model takes and outputs from, thanks to the hub integration. So basically it knows that it's a tabular regression or tabular classification model. So it says, hey, I need to have a table as input and a table as output for batch inference. And it also has an example input section that we previously had with the inference API as well, so that it gives a hint to the user. This title and this description is not loaded from the interface. Unfortunately, it's something we can customize later on. But the rest of the interface is actually loaded with 1 line of code, and I think it's pretty good because, like, as a data professional, you don't necessarily need to spend a lot of time on creating demos for your applications that you will only use to a client or a stakeholder of your project, and you need to focus on your data, or like you need to focus on your model instead. So that's why this is developed. So basically, if you have a skops model serialized with skops, and if you are hosting it on Hugging Face Hub, then you can directly load this interface into wherever you want. You can also host it openly, thanks to Hugging Face Spaces. As I mentioned, it's the type of repository where you are hosting Streamlit or Gradio or JavaScript or whatever you want based data or machine learning applications. And lastly, if you want to learn more about this, we appreciate, so you can check our documentation. You can contribute. We currently, like, the code base is not that big at this point, so it's a nice place to contribute, I would say. There are a bunch of open issues. You can also open issues, and we appreciate this more than anything because, as I said, the secure serialization is still experimental, and we would like someone else to break it and just tell us, what can be improved. And you can check out the scikit-learn organization page on Hugging Face Hub, because we feel that with scopes examples and cool Gradio demos of scikit-learn examples and more. And yeah, like if you want to read about the Gradio integration, you can also check that link. So, and my talk is over, so I can accept questions. So Valerio, hello. Valerio said, if it's okay, I can answer.
Okay. Thank you very much. I want to remind you that you said you want to write a line of code. A
Yeah,
line
I'm
of
going
code.
to. Yeah. I'm going to write it, but I would like
Okay.
to answer a couple of questions first. So, is it possible to deploy this application outside of Hugging Face? Yes, you can deploy it wherever you want. It's essentially like you can deploy it on your local, and there is a parameter called share when you are launching this. Let me send you a code snippet, just a second. And it's essentially opens an ngrok tunnel, and it's served for, I think, 72 hours thanks to Gradio. Like you don't necessarily even need to shut down your computer, like it's served. It also runs in Colab, it runs in many places. You can even embed this. Like you can, the best part of using it in Spaces is that if you host it in Spaces, then you can embed this to your blog posts. Like you can have interactive blog posts, which is very cool, I think. But you can have it wherever you want, because like Gradio is open source and it wasn't essentially developed for Hugging Face in general. I'm going to send documentation of Gradio, just a second. And later skops integration. I'm going to send this to the backstage if it's okay, because I cannot post. And Gradio skops integration, just a second, it's here. My computer was lagging a little. So it's just one line of code. I'm going to send this again privately, and you can see. You don't need to do debugging part, sorry, but if you want to share this with someone while serving on your local, you can set share equals true. Can you send last snippet that I posted? And I saw 2 questions. What data format skops support when integrating with Hugging Face Inference API? So currently, because this serialization feature was launched in the main, was launched with the recent release. It wasn't a mainstream thing. It was being developed for a long while. Currently, Inference API only supports Pickle, but we will integrate the skops format very soon. And is the model card intended for a single instance of a model or a general model class? It's intended for a single instance of a model, because it contains model specific things like hyperparameters or the pre-processing stuff that you have used. So it's actually makes sense because you can version your experiments using this library, and it's lightweight compared to other versioning libraries, I would say. And let me see. So in the last snippet I have posted, you can just call that. So basically what you're doing is, I'm going to show that slide. So this is this interface has been constructed by calling the last snippet. So what I'm doing is I call the scikit-learn / tabular playground model from Hugging Face Hub. So I need to prepend it by Hugging Face so that it knows that it has to be called from that place. And I am passing a title, which is the Super Soccer defective product prediction one. And I can pass a description, and then I call launch. and this will be launched. And if you set share equals true, you can just create a host that people can try with. And if you want, you can host it in spaces and then embed that space to your website, to I don't know, like blog. This also runs for 72 hours in one notebook instance, which is very cool. Like if you have a Jupyter notebook or Colab or whatever, you can just call it from there. Yeah, I think there is no other questions. Do check out Gradio. It's a very cool API, I would say. It makes things very easy.